As you've heard, my name is René. In my day job, I work at a company called 5 Minds IT Solutions. 5 Minds is a premium provider of custom-made software for clients from a variety of verticals, which basically means that we're doing business with energy companies, financial institutions, hardware retailers, and automotive suppliers, just to name a few. Recently, we have also started developing our own product, which revolves around the analysis, execution, and inspection of business processes. If you want to reach me, you can find me basically everywhere in the internet under the handle René with a triple R. Now, I usually like to start talks with a thought-provoking quote, like most of us, but I don't have to do that today, right? Credo is king of the hill in Elixir land, and using linters in general is an innocent joy only rivaled by 2 pineapples having a party, right? Well, believe it or not, but I have my qualms with the way linters are used and viewed in our industry, and I even wrote a blog post about it earlier this year, because for me, this is about a decade-old struggle with analysis tools. To quote from the article, the usage of linters, tools to analyze your code and tell you where it can be improved upon, is becoming more widespread in recent years. Many programmers nowadays start their careers in a place where a CI system runs ESLint, Rubocop, or Credo against all their check-ins. Overall, this is a good thing, because it allows discussing code quality issues within teams more openly and in a transparent way. You can imagine there is a but. Yeah, I know. Publishing my own misgivings on the internet is not the nicest thing to do, but A, this post gets really constructive towards the end, and B, for me it's really better than having no hobby at all. But seriously, having posts like these enable us to ask an important question. What is the purpose of using a linter? What are we looking for? And once you start asking these questions, there are follow-ups. What are we training people for? What is the usage of a linter supposed to accomplish specifically? One could argue it's about code formatting, or about uniform appearance, or coherent style, or about ensuring a great quality of the code submitted for review. If you ask me, and Brooke touched on this earlier this morning, it's really about mastering complexities, because most software grows over time. And like we all like to pretend that none of what we do is rocket science, even the most mundane CRUD app increases in complexity with each new feature, and soon we are faced with a hairy ball of complexity that lets us forget about our dreams of rocket science. It's also about managing expectations regarding our source codes and its potential, because we are forming opinions based on the linter results. And while this is a high-level view, we can go a little deeper. It is a lot of having a sense of improvement. And it's also about taming code smells. It's about trying to keep people from shooting themselves in the foot, and thank you for the term foot gun for this, by preventing errors before they occur. But in some cases, and that is what the blog post wanted to highlight, these self-imposed restrictions might prevent improvement by themselves. Most linter setups are far too strict, and more often than not copied off of the internet without reflecting one's own use case. In one of my favorite movies, Good Will Hunting, the main character shouts at the judge, "Liberty is a soul's right to breathe." And maybe someone more poetic than me can find a similar saying for linter rule sets. And sometimes I think people want these rigid rule sets because they offer a kind of comfort. Taking the poison you know seems to be less frightening than confronting the question which poison you prefer. And this is evident if we look at how successful Dogma was. It was the first Elixir linter, and as the name implies, it was pretty dogmatic and strict. And although I had a couple of philosophical differences with its approach, dogma is the sole reason Credo exists. Coincidentally, Jose tweeted something during Credo's early development that really resonated with me. Maybe you're wrong is enough for talented singers and developers. It is really far from enough for the rest of us. We need guidance. So when asked on the Elixir Wizards podcast what my goal with Credo was, I stumbled on my words a bit, declaring that I wanted Credo to be kind of a mentor, a digital mentor, a robot mentor for people, because I was fortunate enough to have a human one, which is a privilege that not everybody shares. And I think now more than ever that this is what really got me started in this direction. So, after the bleak blog post in the beginning, here's some positivity for you. Also some positivity associated with Twitter, for what it's worth. Credo wants to be a tool for mentoring people, and today I think that this fact might be the single most important reason why Credo managed to outrun other tools in popularity. But it is also equally important to note that I could not have known this when I started. There wasn't a grand plan, and most of the things I am able to tell you today are conclusions found in hindsight with 2020 vision. For this talk to work, you have to understand that Credo was born as an experiment to create a digital mentor that helps with onboarding people into Elixir. And this is what Credo looks like today. Just to get a feel for the room, who here has heard of or used Credo? Wow, that's pretty much everybody. Nice. I will still explain how it works. You can see here how issues are grouped by type, with code readability being the only type in this short example. For each issue, there is an arrow indicating the priority. There is a message for each issue containing the call to action. You can also see that not all the issues are shown. In the actual Credo output, we show the top 5 issues per category, and I shortened it to 2 issues and just 1 category for this presentation. Credo can also be wrong, so there is a distinctive call to action for submitting issues on GitHub. There's information about how long the analysis took, and how many modules and functions were analyzed and how many issues were found. And then again, there is a hint that we are not showing all the issues at once and that low priority issues are omitted from this report. The unique thing is that while many tools give you the location of an issue, in Credo you can use that location to get an explanation for what the issue actually is. You append the location to your usual mix Credo command, and you will get this. What we see here is again the category and priority of the issue, as well as the issue's message and location. Then we have a section called Code in Question, which shows the code triggering the issue, and a section why it matters, which contains an explanation in actual English. In this case, that numbers can contain underscores for readability purposes and that they do not affect the value of the number. This really speaks to the user in an accessible way. At the bottom of this output, it is also shown, it shows you the configuration options, which contain a section explaining all the configuration options for the check that triggered the issue. And this is all super nice and friendly. And I think I can, as I said before, attribute a lot of Credo's success to it being approachable and it using accessible language. But none of this would matter if we did not have solid analysis as a foundation. And one of the things that I learned during my brief stint as a scientist is that you have to question your assumptions. So before we get into how Credo's checks work, let me tell you a thing or two about its analysis. In computer science, an abstract syntax tree is a tree representation of the abstract syntactic structure of your source code. In a way, it's your source code as data. Each node of the tree denotes a construct occurring in the source code, like module declarations, function declarations, and function calls. An Elixir AST mostly consists of 3 element tuples. The first element is the operation that the tuple represents. The second element contains meta information, like on which line in the source code this construct can be found. And finally, the last element is the arguments given to the operation. So what does this mean in practice? Let's look at some examples. The Elixir code is always shown in the upper right and the AST on the left. And if we look at 1 plus 2, this is the AST representation of that construct. We can see here how the infix operator is our operation in the AST tuple, and how the numbers 1 and 2 are listed as the arguments to that operation. Second example, we are piping a variable sumvar into a function inspect, which is called with a keyword list containing label foo. If we look at the AST representation, we can see how the pipeline operator is our operation. And the pipe variable sumvar is the first argument to the pipe operation. And you can see here how variables are represented as operations with the arguments being nil. And the inspect call is a function call with a keyword list as its only argument. What we can see in this example is how the AST does not inline the pipe, nor does it modify the source code in any other way. It is just an abstract representation of the source as data. And there are also other constructs which are not represented as 3-element tuples. I won't get into those at this point, but there's, as always, excellent Elixir documentation, which is linked below. So, why is this useful? Let's look at an example of how we can utilize this for analysis. And the example will be calling IEXpry. For those unfamiliar with IEXpry, when we have a module and call IEXpry inside a function, pry allows us to jump into an IEX session right inside that function. We get there by calling IEX-s, which executes a given script, and we give it mixed run-e as the script which evaluates a given command. And with the command being myproject.add1 and 2, we end up in our IEXpry call. And from there we can use local variables to explore the state of things. Now this is something we do not want in our production code, which is why Credo has a warning for it. And to understand how Credo can warn us about these calls, we have to look at the AST again. And this is what the AST example looks like. And our function call is right down there. And this is the snippet we have to find inside the AST to warn about this issue, which begs the question, how do we actually find anything in an AST? And this is where the Elixir standard library helps us out. There are 2 functions, pre-walk and post-walk, and as you can see in the upper right, we are using pre-walk in this example. Suppose we have the AST on the left and the macro pre-walk call on the right. We inspect all the parts of the AST in the order in which they are yielded by pre-walk. And I will now go through what the order would be for pre-walk. We would first get the whole dev module AST, and then the first argument to it, and then the first argument to that, and then the second, and then this. And this might be a good example to show you what pre-walk actually does. It has a 3-element tuple, and the next items will be the arguments to that operation, like in this case the variable a and b. And then we're going on, and this would be another great example. We have the match operator here, just to reiterate the concept. And we first get the whole 3-element tuple, and then eventually its arguments. So we get the first argument to the match operator, then the second argument to the match operator, which in itself is an operation, the plus operator in this case, for which we get its first argument and then its second argument. And this goes on, and I think you got it by now. And eventually, we finally arrive at the node inside the AST which we wanted in the first place. To act on this node is now actually trivial because we can just adapt our code in the upper right to include a clause that matches on the expected AST's pattern. And we could now do anything with this inside that do something block. Okay, so much for the computer science excursion. Let's talk about how actual checks work. And naturally, we will use the IExpri check we just discussed as an example. This is the beginning of the check module. We can see here the use check directive, which initializes the check module with the behavior and the given options. In this case, the check has a base priority of high, and it implements a run function which takes two parameters. The source file, which is a Credo specific struct that needs to be analyzed, and the params given to the check in Credo's config, which is a keyword list. Next, we are using Credo's version of macro prewalk, which knows how to traverse the source tree of a source file. And this means that the traverse function will be called just like the anonymous function in our example before. And here are the two implementations of that traverse function. Let's talk about the bottom one first, because the bottom one illustrates how we get the AST that we're currently looking at, and we return that AST as part of a two-element return tuple. And we also get the issue accumulator as a parameter and return it as a second element of that return tuple. And this way we can accumulate issues by adding them to this list of issues. However, the function we want to match is the one above, where we provide the same pattern we just saw in our previous example. And instead of returning the issue list unchanged, we are adding a new issue to the list using a function called issue4. And for completeness sake, this is the issue4 function which creates the actual issue using a construct called issueMeta, which combines source files and check parameters using a function imported from the Credo check module called formatIssue, in which we have to provide the message for the issue, the trigger, which is the actual piece of written user source code that triggers the issue and that should be highlighted in editor integrations, and the line number in which the trigger can be found. And this is what results in us getting the warning about the usage of IExpri. Now, there might be those rare cases where you want to keep the IExpri call in your production code, and you might know that you can suppress individual issues using this config comment syntax, but you might also find that unacceptable or ugly or both. And you have also read that Credo supports writing custom checks. So you think, maybe I can write a custom check to solve this issue. The code for the following examples will all be on GitHub or is already on GitHub, so you don't need to scribble along. And please note that this code is meant to demonstrate concepts and might, in some places, lack a certain cleverness. But let me assure you that's just for educational purposes. And this is what our new check looks like. Please note in the upper right that this code is situated in the user's project. Just like the code it analyzes, we are building a custom check. Credo will load this check before the analysis based on its config, which we will see in a bit. The difference to the built-in check in our check is that we are actually using the parameters this time. We want to be able to provide a list of files that are excluded from the analysis for this specific check. And to achieve this, we are utilizing a function to get the parameter or default value, and then we find out whether or not the current source file is listed in the excluded parameter. If this is the case, we simply return an empty list of issues. And if this is not the case, we run the analysis like we saw before. So the rest of this module would be the same we saw in the built-in check. We would just copy-paste that from Credo's repo. The user has to prepare his or her Credo config, as is shown here. First, the file with the custom check has to be listed under requires, so Credo can require it. And second, we want to deactivate the original check, which we re-implemented. And thirdly, we want to add our custom check to the list of checks. And with this, the output of Mix Credo remains exactly the same as before. Because at this point, we have not yet configured our check with this excluded parameter that we just invented. But when we add this excluded parameter to the configuration of our custom check, the warning goes away and we are left with the readability issue. Now, sometimes custom checks are not enough and you get this feeling that you have to rewrite the rules. The promise of plugins is that Credo has always been about putting an emphasis on teaching people, and we are now ultimately empowering teams of Elixir programmers to teach each other. With plugins, users get ultimate control over Credo's execution pipeline, and they can use Credo's utilities to teach their teams about the things that are really specific to them, their situation, their context, or their project. At the center of this little marketing piece about plugins is Credo's execution pipeline. And although this might sound fancy and grandiose, you probably already know pipelines just like the one in Credo. Because Ecto change sets and plug connections follow the same principle. They represent an intent, a token that is handed down a pipe. An Ecto change set is a struct that goes down a pipeline of validations while preparing, in most cases, a database query. And a plug connection gets transformed while a server prepares a response to an HTTP request. In Credo, the token that is handed down the pipeline is called Credo execution, since it contains all the relevant information for a single execution of Credo's analysis. The struct flows through different stages, which are themselves either named groups of tasks or, in some cases, fully fledged pipelines themselves, for example, in the case of certain commands. Also, please note here that this is an oversimplified illustration. The pipeline in Credo's case is not a series of Elixir pipe operators chained one after another, but rather a field inside the execution struct itself. I mentioned that this struct holds all the information relevant for single execution of Credo. It holds the argument vector, the CLI options, all configured checks, found issues, registered plugins, known commands, and config files. It also has this interesting field called halted, which tells the execution mechanism whether or not to keep executing tasks, very much similar to the way plug does it. And then there is a map of pipelines associated with the execution. And this map of pipelines contains the Credo execution pipeline as well as other pipelines, for example, those of individual commands. Each pipeline consists of named groups of tasks, and you can think of these lists like plug pipelines, grouping tasks to run at the certain stage of execution. And if we look at one of these named groups, resolve config in this case, we can see that they contain those task modules. These modules are simply implementing a call function which receives the current execution struct and returns an updated execution struct. And this is how we can control the pipeline with plugins. We prepend or append our own task modules to these groups. I'd like to show you a minimal plugin next, but to talk about the different aspects of plugin development, we will need these badges to help us identify where the shown source code is located, because that can actually get a bit fuzzy when talking about plugin development. We will have parts that are from Credo source code, examples of plugin source code that a plugin author has to write, and examples of a project, of a user's project code and config, which the user has to provide to use the plugin. And here is the first example of the last category, a green badge in the upper right that is user code. The usual way for users to use Credo plugins is to reference them as a dependency and put the two-element config tuple in the config file under the field plugins. Plugins, as you can see, are configured by the same kind of two-element tuple that checks are. The minimal viable plugin is shown here. It is just a module implementing an init callback that takes an execution struct and returns an execution struct. And this is a more complete example that shows what we can do during plugin initialization. So we can register an additional default config. This will not override the user's config, but take precedence over Credo's own default config. We can register commands, which means that in this case I can now type mix credo demo, and then the demo command gets executed. As plugin authors, we can also register our own CLI switches by providing a name, type, and optional shorthand, and these can then be used during runtime by the plugin's code. And lastly, we can modify Credo's execution pipeline by prepending or appending custom tasks to the different predefined pipeline steps as we saw before. So let's write a plugin that actually does something useful. Think back to our custom check, and we are still having this readability issue. And now the question becomes, how do we get rid of that? I mean, okay, we could document the module, but who wants to do that? So we could now go on and re-implement the check as a custom check as well, just to support this exclude parameter we just invented. But re-implementing all the built-in checks in Credo just to get this to work would simply not scale and seems unreasonable. So what if we did not have to re-implement every check in Credo, but could add this please exclude these files for this specific check functionality? Wouldn't it be great if a user could simply use the excluded parameter we invented in our custom check with every other check? We could write a plugin that looks at the found issues, looks at the configuration for the check that raised the individual issue, and exclude the issues where the issues file is among those excluded in the check's configuration. Sounds easy enough? Let's do it. This is what that plugin would look like. We are appending a task to the determine issues group inside the suggest command pipeline. The suggest command is a command that's run by default when you type mix credo. So we are now actually affecting not the overall execution pipeline, but are targeting the pipeline of a specific command. And the task module which we append here will allow us to filter issues from checks that have the excluded parameter configured. And after we have filtered out these issues, we also want to report the filtering to the user just to provide some transparency to the process. Filtering out the found issues is not that hard. We won't have time to get into the details here, but you can find this code online. Basically, to give you a quick overview, we are retrieving all the issues found during analysis. We are then extracting the configurations for the checks which raised those issues. and then ignore those issues where a configuration parameter was set to ignore the file in which the issue occurred. Lastly, we assign the number of ignored issues to a variable so we can use it later, and set the issues of the current execution to those not ignored by our filtering. And the task that does the reporting is trivial as well. We are getting the assigned variable back and are printing a hint based on the number of ignored issues. That's it. And to utilize this, the user has to include the Credo check filter config plugin we just created. And then he has to configure the built-in module doccheck with the parameter we just made available for all checks. And now the issue is gone, and our special output is also there in the last line. The last example for today will be integrating an actual third-party tool that has to run before we can integrate its results into Credo's analysis. And I want to use a tool of mine, a predecessor to Credo, a spiritual predecessor, that analyzes compiled Beam documentation. And this project is called Inch. It was started 5 years ago, and it is an analysis tool for inline code documentation which identifies present documentation in modules and functions. And it assumes that not all of these elements are equally important to be documented, and it assigns a priority to give it a relative importance based on a pairwise comparison. And it also assigns a weighted score representing how good the documentation for any given element is, based on a biased framework that has no claim to be objective whatsoever. And what Inch achieves is focusing the user by suggesting certain aspects of the job at hand instead of presenting everything at once. It is able to explain to the user how it arrived at its conclusions and how a score was determined, and it does not demand for all items to be documented, and it does not obsess about numbers or any other metric. In fact, it does not even display numbers, but rather displays grades. And this is what it looks like. Any similarities to Credo are completely superficial. You can see here that we have 3 sections in the results, and that you can see that not all the results are shown at once. First, we get a couple of objects that get a B, with the little arrows next to the grades indicating the priority assigned to the object. And below that, we see a couple of undocumented objects. And those are assigned a special grade U, because I thought it important to not give them an F for undocumented if we want to convey to the user that not everything needs to be documented. And at the bottom, we don't have an overall grade either. Instead, we see a distribution of grades which enable you to reason about how much your code base is documented. And that is much different from the usual 67% of your code base was documented. As with all the examples, the code for this one can be found online, and this is also the one plugin that might eventually see the light of day in terms of production readiness and become a Hex package. The version presented today is more of a proof of concept to show off Credo's plugin capabilities. Our goal here is to replace this regular issue with an issue generated by Inch, which actually looks into the compiled Beam documentation and takes, for example, metaprogramming into account because of that, and allows for a much more differentiated analysis. Again, the plugin module itself is super simple. We are registering a default config, which we will look at in a second, and we prepend a task to the initialize plugins group, which is a group where plugins can put tasks that initialize things. And our initializer task, aptly named Ensure Project is compiled, is both very important and very mundane. It simply ensures that the user's project is compiled before Credo runs. But this is a revolutionary thing, since Credo is a static analysis tool which does its analysis by merely reading the source code. And this means that plugins allow us to do things which Credo, by definition, isn't allowed to do. And this is a config that is added by the plugin, and it, like the other examples, deactivates an existing checks and adds a new check. Since we can be sure that the user's project is compiled as soon as our new check runs, this one can run inch to find the compiled documentation programmatically inside the Beam files. And here's what the check looks like. So this is a proof of concept, which is why I will go over it rather quickly. In this module, we are using the use Credo check directive to create a check module, and this time we call it with an option run on all being true. And what this does is it runs the check not on each source file individually, but rather it calls another run function that accepts all the source files and execution struct and the check's configuration parameters as its 3 arguments. We are retrieving a parameter from the check's configuration like we did before. Then we run inch, which returns a list of results that we then filter for the defined minimal priority, and then make the remaining results into Credo issues. We filter out all the nils and then append the issues to the current execution. For completeness sake, this is a filter function that's not very spectacular, and this is the issue mapping function. And you can see here where it says source file equals enum find that we have to make sure that the source file we are talking about is actually one that is included in Credo's analysis. Because when we open up the Beam files to get out the documentation, it's all the documentation. Also for files, naturally, that you did exclude from your Credo analysis. And this is the issue for function that either creates an issue or not based on whether or not a source file was provided. And now the user just has to include the plugin in his or her Credo config. And now we have reached our goal of having an issue which was generated from a third-party tool. You can see this because it mentions the grade that inch gave to the element. Now I want to show you one more trick. If we add the Credo check filter config plugin we developed earlier and add the excluded parameter we know from before to the Credo inch check we just developed in the last example, what do you think happens? We're back to no issues found. And this is a great example of how 2 plugins can be composed to work together. This is possible because they change the workflow independently of one another, and these changes are simply composable. Which leads me to the final slides, a roadmap for Credo 2. Although this is not a strict roadmap, it feels more like homework, in that there is a lot more we have to think about now. Before, it was only Credo's contributors and myself who were affected by internal API changes, but now much more of the APIs around issue creation and check parameters and configuration management are open for the general public, so they can be leveraged by the user's plugins. So as for the homework, I want to explore options to separate the backend and the front end, because we saw how we can modify pipelines to modify execution, but we do not yet are able to modify the output or have a Credo server that runs the analysis without having a TTY to write on. We should also explore the slow-moving parts of Credo, maybe even rethinking how checks are executed. You saw that there is a distinction between checks that run on all source files at once and those that run on every source file individually. And I'm not sure that we need that distinction and that it maybe even hurts the execution speed. We might also want to rethink how issues are created in terms of all the params and issue meta and format issue and all the other stuff that was up until now sort of underwater because only I had to deal with it. And we have to answer the question, how should plugin authors test their plugins? I mean, it's just modules and functions, but that might not be enough here. Maybe we want to provide a thin layer of testing helpers. And lastly, Credo has always been strong in shaping the newcomer experience. But much has changed in the past 4 years since Credo's inception, and we should take the time to reflect on that. And that's all I had for today.
Thank you. We learned a lot. Any questions?
Thank you very much for your talk. It was really insightful to see what all is going on inside of Credo. One question about this is the example check that you showed works on the Elixir abstract syntax tree. But if we're talking for checks like the ones where Credo tells you, hey, you're usually using, when writing a comment, only one space, but here you're using multiple spaces before starting text. Are those then just using strings and regular expressions, or is there something more clever or another way that you can work with that inside of Credo?
That's a very good question, and I want to thank you for using the word clever, because I can now say yes, super clever. There are basically 3 things we use in Credo for code analysis. That is the abstract syntax tree, that's the tokenizer that's provided by Elixir, and in some cases, raw string analysis. For the check you mentioned, it's mostly that we look at the tokens, because the tokens have a line and column number, so we can see when they are apart and when there's white space in between.
It was just that test you had, you checking the syntax tree for IEX and then pry, and then you had like for the explanation you had the string IEX.pry for the highlighting, I think you said. Does it mean if you put a space before the pry that it doesn't see it, or? No, okay. You mean in this one? This one, yeah. Okay, so basically we could say at the trigger IEX.pry parentheses opening and parentheses closed. Probably that would be better. But the trigger is just there for editor integrations to tell them what the substring is. You could also give it the starting column and the end column by hand. This is just a convenience for the checks that are looking for a very specific pattern so that they can write the pattern as a binary and say, okay, that in that line, and we're mostly done with it. It's not the safest way to do it like this.